ವೆಂಕಟೇಶ್ ಇದ್ರಲ್ಲಿ ಹಾಕ್ಬಿಡಿ, ಗ್ರೂಪ್ ಅಲ್ಲಿ CSC ಗ್ರೂಪ್ ಅಲ್ಲಿ ಯೂಟ್ಯೂಬ್.
ಎಸ್ ಮೇಡಮ್, ಹಾಕ್ತೀನಿ ಮೇಡಮ್.
ಸರ್ ಕಾಲ್ ಮಾಡ್ಲಾ ಮೇಡಮ್?
ಒಂದ್ ನಿಮಿಷ ಬಿಟ್ಟು ಮಾಡಬಹುದು. ಇನ್ನು 59
5 minutes
11 ಜಾಯ್ನ್ ಆಗಕ್ಕೆ ಹೇಳ್ತೀನಿ.
Good morning, Deepa madam.
Good morning, sir. Good morning, Dilip. Good morning.
Good morning, sir.
Good morning, sir.
Yes, sir.
Good morning. Good morning, Kishore sir. This is Dilip Kumar.
Yeah, good morning, sir.
Sir, our chairperson, sir, chairperson of the department, Dilip sir.
Right. Yeah, I interacted with him. Blockchain.
Yes.
Yes, sir.
ಲಾಸ್ಟ್ ಆಗಸ್ಟ್ ಅಲ್ಲ, ಆಗಸ್ಟ್ ಅಲ್ಲಿ ನಿಮ್ದಿತ್ತು, ಸೆಪ್ಟೆಂಬರ್ ನಂದಿತ್ತು.
Yes, madam.
ಫಸ್ಟ್ ದಿಲೀಪ್ ಸರ್ದು.
ಹೌದು ಹೌದು.
There is also Dr. Dilip, who is quite an advocate of distributed autonomous systems. He is a senior vice president of Reliance now. Earlier he was with IBM and Qualcomm. So he is a great staunch supporter of blockchain in many of them.
Good morning, sir. So VC sir has come.
Good morning, sir.
Good morning, sir.
Morning, good morning.
Good morning, sir.
To all of you.
Good morning, sir.
Good morning to all of you. Morning.
Good morning, sir. Good morning.
So ಬೇರೆ ಬೇರೆ ಕಡೆಯಿಂದ ಬಂದಿದ್ದಾರೆ ಸರ್, ಬೇರೆ ದೇಶದಿಂದಲೂ ಇದ್ದಾರೆ ಪಾರ್ಟಿಸಿಪೆಂಟ್ಸ್.
Okay. ಈಗ ಇದು ಕೆಸೆಟ್ ಎಕ್ಸಾಮ್ ತಗೊಂಡಿರೋದು ಒಂದು ಮೀಟಿಂಗ್ ಕರೀರಿ, ಕೋರ್ ಕಮಿಟಿ.
ಸರ್ ಕೇಳಿಸ್ತಿಲ್ಲ.
ಕಂಪ್ಯೂಟರ್ ಸೈನ್ಸ್ ಕೋರ್ ಇದು ಕಮಿಟಿ, they have taken KSET exam, computer science and application.
ಹೌದು.
46 students.
Yes.
Sir, 47 in total.
So they please call for a meeting with the principal, the chairpersons, the dean, and the core committee OSDs.
Okay, sir.
ಸ್ಟಾರ್ಟ್ ಮಾಡೋಣ ಸರ್.
Yeah, start ಮಾಡಿ.
ಸಂಯಮ.
Yes, ma'am.
Good morning, everyone. It's an honor for me to welcome the galaxy of intellectuals who have gathered here. I, Samyama Gunjal GH, welcome you on behalf of Department of Computer Science and Engineering, UVCE, for today's webinar on research and development opportunities in 5G, beyond 5G, and non-terrestrial networks, that is NTN, which is technically supported by IEEE Computational Intelligence Society, Bangalore chapter. A series of webinars are successfully organized and conducted by Department of Computer Science and Engineering, UVCE. Before going ahead, let us seek the blessings of the Almighty by an invocation song. Now I request Ms. Tanushri, 3rd SEM CSE, to seek the blessings of the Almighty. Tanushri.
Good morning to one and all. Ekaya Ganadaivataya Adhyakshaya Dhimahi Manditaya Guneshyanaya Dhimahi Gunaditaya Gunadishaya Gunapravishaya Dhimahi Ekadantaya Vakratundaya Gauritanayaya Dhimahi गजेशानाय बालचंद्राय श्री गणेशाय धीमहि. Thank you, Ananda.
Thank you, Tanushri. Now I request our webinar coordinator, Dr. Arunlata JS ma'am, Professor CSC, to welcome the gathering.
Yeah, good morning, everyone. On behalf of the Department of Computer Science and Engineering, UVCE, I, Dr. Arunlata JS, Dr. Venkatesh, and Samyama Gunjal GH, webinar coordinators, are truly delighted to welcome you all for today's webinar on research and development opportunities in 5G, beyond 5G, and NTN, which is technically supported by IEEE Computational Intelligence Society, Bangalore chapter. It is with great pleasure that I heartily welcome our Honorable Vice Chancellor of Bangalore University, Professor Venugopal Kyas sir, to this webinar. Welcome, sir.
Namaskar, namaste. Good morning to all of you.
Good morning, sir.
Good morning, sir.
It is with great pleasure that I heartily welcome our principal, Professor H.N. Ramesh, UVCE. Welcome, sir. I would like to extend a warm welcome to Professor P. Deepa Shanaik, Dean, Faculty of Engineering, Professor, Department of Computer Science and Engineering, UVCE. Welcome, ma'am.
Thank you. Good morning.
Thank you. A warm welcome to Professor Dilip Kumar SM, Chairman, Department of Computer Science and Engineering, UVCE. Welcome, sir.
Thank you, madam.
It is indeed a pleasure to welcome the speaker of today's webinar, Flight Lieutenant A.T. Kishore, CEO, Vidyasangha Technologies Private Limited. Welcome, sir. I warmly welcome all the faculty members of the CSE department, faculty members of UVCE and various other institutes, guest faculty, research scholars, students, and the participants from the other countries, all other participants. Once again, I welcome one and all present here for this webinar. Now, I request our Honorable Vice Chancellor, Dr. Venugopal Kya, sir, to address the gathering. Over to you, sir.
Yeah. Thank you very much. Thank you one and all for giving me an opportunity to address this August gathering, erudite gathering, students, teachers, and also people from across the country. Today's topic is 5G, then NTN, and beyond 5G. So what is that which you are going to learn from today's webinar? If you're seeing the technology which you're using now, there is delay in what I am talking and what you are listening to, a delay of more than 200 milliseconds or more. When the bandwidth constraints are there, the speed decreases, latency increases, and that's what we are going to talk about in today's webinar. The 5G technology is really amazing. It goes beyond our imagination. And if you see the things that are going to come in 1 decade from now, it is even beyond the science fiction which you have read in books. What appears to be a story today, it is a reality of tomorrow. I would like to bring in few characteristics of this 5G networks which are going to be available in 2 to 3 years in India, and it is already available elsewhere in China and Singapore and Australia. Whenever we talk about networks, you know that I've been teaching networks for the last 30 years. And Tannenbaum is like a Bhagavad Gita. A person who is in computer networks would have gone through that book. And I have studied that book from page to page in Indian Institute of Science when I was doing my ME. And in IIT Madras when I was doing my PhD. And I was teaching the students of B.Tech and M.Tech in IIT Madras when I was doing my PhD. my teacher in computer networks in IIT Madras, Timothy Gonsalves. He used to give us test only in 10 pages of Tannenbaum. And everybody thought it is so easy. And the highest mark was 62 marks out of 100 in the 10 pages, open book. And mind you, used to give the first question as 1 mark, grace mark. What is your name? So that you should not get 0. And in that type of test, I stood first in IIT Madras in computer science, computer networks. And you know, it is so interesting to teach networks to students. In my journey of 3 decades, I moved from computer networks to optical networks to wireless networks to sensor networks, and now to non-networks. Why I'm telling not networks? Everybody is connected. Everybody is connected, and then you don't talk about networks at all. So this 5G technology is going to bring you an amazing experience, and in one's life, especially to those youngsters, the way we have seen life and the way you're going to see life will be completely different. One, the bandwidth. We're all, you know how this online classes has given us some bitter experience of that when you want to switch on the video, you will not be able to transmit your audio, and therefore you will switch off the video and then start talking. So the bandwidth available in 5G is 10 Gbps. The delay will be 1 millisecond. In 4G, it is 200 milliseconds or 100 milliseconds. Now imagine our eye can capture continuity by 1/16th of a second. If it is less than 1/16, so you will not be able to see the change. That's why when you see a movie, that movie will be running at a rate of 25 screens or frames per second. The alternate lines, there are 525 lines on a TV and 625 lines on an American TV, which is adjusted to the frequency, 50 hertz or 60 hertz. So in a 50 hertz, we have 525 lines and 262.5 lines in the first screen, and in the second screen, another 265.5 lines. And so there is continuity. So when it is 1 millisecond, that means you will not see the difference at all. In the camera which you're capturing and the speed with which is moving the video, you'll be seeing more reality than virtuality. Especially with the 3D images, with the holograms, you will feel that the person is with you, sitting beside you. If you have seen the hologram technology that was used in the last election, you saw the Prime Minister coming onto the stage and speaking to people. This is because of bandwidth. This is because of reduction in delay. And it is going to be much more in years to come. What about the energy? Every time you'll say that your mobile is switched off. Every time you say after 1 hour, I am running out of energy. Now, with this 5G technology and with the improvement in energy efficiency, if you are able to charge your device that device will not require recharging even in next 10 years. There will be 90% efficiency in energy. And see what the magic which you have. I am carrying now a box of chargers, box of connectors, a box of plugs, so that I should not run out of energy. So this 5G technology and the improvement is going to change the way you live and the way you lead your life. Energy efficient 5G technology. What is that which you're going to connect? 50 billion devices. By 2025, 2030, you will have 50 billion devices. Already there are about 10 billion devices. The population of this country, this world, is 7 billions. And you are going to connect 50 billion devices by 2030. And all these devices are connected. You do not know how many devices are connected within your body. Your specs will be connected. If you have an electronic eye is connected. If you have an heart, electronic heart is connected. All these devices by nanotechnology. It can be Internet of Things where the size of the device can be large. Then that size can be smaller. Therefore, it is called nanotechnology, nano Internet of Things. Then people are connected. Then it is called social Internet of Things. Vehicles are connected. Then social Internet of Vehicles. Then industry vehicles are connected. Industry is to industry. IOV. So IoT. Yes, IoT. Yes, IOV. NIoT. IoT. All this requires bandwidth, low latency, less energy consumption, and you know what not. And all this will be incorporated and integrated into the 5G technology. And what is its availability? 100%. What is its coverage? 100%. What is its battery life? 10 years of battery life. What is its energy? Energy is going to be only 1/10 of or 1/100th of what is the energy consumption that is taking place today. What is its bandwidth? 30 gigahertz to 300 gigahertz. So when you have millimeter waves, we will have more bandwidth. The smaller the wave, the higher the bandwidth. That's what you're going to see in your life. That means a car which used to have driverless car, which reacts in about 30 meters in 4G technology, will respond in less than 3 meters. That means 1 inch. You can imagine its response when you meet with an accident, you will get a robo-lawyer. And the robo-lawyer will speak to you where you can take the vehicle and how you can claim the insurance and whatever language you want. This technology is going to change, is brought converged geography, converged culture, converged knowledge, converged information, converged data. Everything is in one shell now because of 5D technology. And how is it going to really affect you? Whether it is vehicle to vehicle or vehicle to human beings or human beings to human beings, or it can be even remote surgery or even simultaneous movements of vehicles which will be connected throughout the world, and you're just sitting at the back seat and trying to talk with somebody, play with somebody, and therefore this technology is going to be a really amazing experience, and that experience will be seen by each and every student who is now 25 years old. You will be actually working with it. If it is 5G technology, what will be 6D technology? How many, when you can say the same parameters are going to further improve. And with that, my thesis in IIT Madras was on optical technology, optical bandwidth. The bandwidth of an optical fiber is 50 terahertz. That means this 50 terahertz is such a bandwidth where whatever you have produced, whatever you have written, whatever you have done, and whatever you want to transmit you can transmit from one end of the world to the other end of the world in 60 seconds. That is the bandwidth of an optical fiber of 50 terahertz. 50 terahertz can connect 9 billion telephones simultaneously. Just one strand of optical fiber, which is 50 nanometers to 125 nanometers in multimode and single mode of 50 nanometers. It can transmit 50 terahertz, and in that 50 terahertz, you can move any data from whatever you have produced in this world from one end to the other end in just 60 seconds. So this is not amazing. It is. It is going to be done. What will happen? We are talking only about terrestrial network. What happens to the non-terrestrial network? It can be on the sea. It can be a geostationary satellite. It can be some satellite in between the geostationary and Earth. All these are going to be connected. That is called non-terrestrial network. If you might be on the ground now. Now we are going to connect everybody. The Triloka Sanchari Narada yen helta idda, so there will be too many Naradas in this world. Adare yak helta idde Narada Triloka Sanchari anta helta idde. With this 5G technology and 6G technology, you will really tell, okay, ಎಷ್ಟು ನಾರದಗಳು ಇರ್ತಾರೆ, ಇವ್ರನ್ನ ಹೆಂಗೆ ನಾವು combat ಮಾಡಬೇಕು, ಹೆಂಗೆ you will be able to fox them, whether it is a spaceborne vehicle or whether it is a low Earth orbits or whether it is a medium Earth orbits or whether it is a geostationary orbits or it is a airborne vehicles, high altitude platforms or unmanned vehicles or lighter than air UAS and heavier than air UAS. All these are going to, have this 5G and 6G technologies, and you will see what happens when you think of even a remote surgery, a place where a doctor in New York will be operating you in Bangalore in Jaydeva Cardiology Institute, and when he cuts a vein there, your vein will be cut here with minimum delay. So smaller the delay, the experience is going to be completely different. And if you see the how these experiences come, it is because of our transistor. A transistor has moved from 11 nanometer to 7 nanometer. There are 4 billion transistors in a Xeon processor. Then Tannenbaum once said, in the race between communication and computation, communication has won the race. Because our processor is just 4 Gbps, whereas our communication bandwidth is 50 terahertz, 50 TBS. So you can imagine what the Tannenbaum visualized 30 years back in this race between communication and computation. Communication has won the race, and today what Kishore is going to speak is that how communication has really won the race with respect to computation. If you have optocomputers, only then you can match, and optocomputers is going to come little later. And that means you have an optical memory, you have an optical processor. Only when you have optical memory and optical processor, then the speed with which you can compute can match the speed of the bandwidth of the optical fiber. Now, still that is some time away, some distance away, and therefore we still live in the age of communication has won the race. And today Kishore is going to speak on that. And I thank Kishore for coming and giving his expertise and giving his knowledge, sharing his knowledge with this, young faculty of Bangalore University in the Department of Computer Science. So thank you one and all for giving me an opportunity. And thank you, Varuna, that she has been telephoning me 10 times, 20 times. Still I come here and talk something for 5 minutes. She will not. And thank you very much. And you know how difficult it is for me. There is a next program and the telephone calls. Yeah, but I'll be listening to you, but I'll be traveling in the car. And thank you for the technology that has come and made this possible and made what is possible, that we are able to communicate wherever you are, anytime, anywhere, anyone, any length of time, any language, any media, and any device. Thank you, one and all.
Thank you, sir. Thank you so much.
Sir.
Thank you, sir.
Thank you, sir.
ಸರ್ ಮಧ್ಯಾಹ್ನ ಇನ್ನೊಂದಿದೆ ಡೇಟಾ ಮೇಲೆ ಸರ್.
Sir, you made that job quite easier for me also by summarizing everything in such spontaneous and vivid memories back to Tenenbaum, and a lot of calculations you have done. Fantastic, sir. I mean, I'm very happy. Other than teaching also, I would like to meet you sometime when all these COVID things will be over.
We are meeting now. We are already meeting. I told this hologram effect and the 5G
Right.
technology and 6G technology will
Right.
make us feel as though we are meeting physically. The
Yes,
virtual has become physical, and social distancing has brought us very close to each other. So this social distancing is
As
actually
attendees,
real.
people from US, they also learned from IIT Roorkee Sanskrit with me. So there are many attendees. So interesting that they are able to listen to you, sir. It's our pleasure.
So thank you, Flight Attendant Kishore, and we'll look forward to your expertise and your delivery so that I'll also be able to listen and take something from you so that I can deliver somewhere else. Thank you,
We will
so
do
that I can copy. Thank you.
Thank you. Thank you, sir.
Thank you, sir.
ಸರ್ ಒಂದ್ ನಿಮಿಷ ಅರುಣ. ಸರ್ ಮಧ್ಯಾಹ್ನ ಇನ್ನೊಂದಿದೆ ಸರ್ ಡೇಟಾ ಮೇಲೆ. ಆಮೇಲೆ 24th ಯೋಗ ಮೇಲೆ ಇದೆ ಸರ್. ಯೋಗ ಮೇಲೆ 2 hour ಸೆಷನ್ ಇದೆ ಸರ್.
24th. Now you are talking to me. It is
24th.
also like
Time
virtual invitation.
ಹೌದು. ಇಲ್ಲ ನಾನು ರಿಯಲ್ ಇನ್ವಿಟೇಷನ್ ಕೊಡ್ತೀನಿ. ನಾನು ಸುಮ್ಮನೆ ಹೇಳಿದೆ. This is only for information.
Okay. Okay, ma. Thank you.
Okay, thank you, sir.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Now I request Dr. Venkatesh sir to introduce the speaker of today, Flight Lieutenant A.T. Kishore sir. Venkatesh sir.
Yes, madam. Good morning to everyone. It's an honor. It's a great honor for me to introduce eminent speaker, Flight Lieutenant A.T. Kishore, to the August gathering. Sir has 32 years of long professional experience in the diverse fields includes aerospace, defense, and telecom. Currently, Sir is Chief Executive Officer for Vidya Sankha Technologies Private Limited, Bangalore. During 2014 to 19, he was served at UTL Technologies as a principal consultant, telecom, emerging protocols, standards, curriculum design, courseware presentations, build, platform preparation, delivery. Flight Lieutenant A.T. Kishore has domain knowledge of wireless evolutions of past five decades and future roadmap of 5G and beyond 5G. Sir has direct involvements in all IEEE events of the Communication Society, IEEE PES, IEEE Computation Intelligence Society, IEEE Robotics and Automation Society, IEEE Education Society, has been executive committee member of several committees and initiatives. He is a mentor for Smart India Hackathon initiated by Niti Aayog since 2017. Atal Innovations Missions. Sir has received long service award from Bell Labs Innovations, Lucent Technologies. His technological leadership profile includes Indian Air Force, aeronautical engineering, telecommunications, product development, and customer support. Now, Sir is leading in BIS in the standard work. Once again, I welcome you, sir, for today's webinar. Over to you, sir.
Thank you very much. And without much delay, let me just start sharing my screen and then get started.
Yes, sir.
Hopefully you see the last slide of my presentation.
It's visible, sir.
Okay, in fact, as one of the 7 principles of highly effective life, I think we begin with the end in the mind. So this is what end of my talk we would come to. In fact, my job had been greatly simplified by extempo speech. I never heard the senior most leader of an education institution giving minutest calculations of latency and taking the attendees already halfway through the journey or completing it through. In fact, I was floating on the spacecraft called Planet Earth, 30,000 kilometers per second it floats, and due to inertia, we all don't feel about it. But I think speeches like Dr. Venu will actually make us feel we are actually cosmonauts and space travelers. And then so I am just trying to reduce that speed and bring you back to planet Earth by keeping the feet on the ground and touching the sky with glory. This is what my Air Force also made me to get tuned to. So get excited about ideas and also try to implement them practically. So it has been my privilege, and to this today's my great discoveries speech by Venugopal sir, and really hats off to your technical think bent of mind at this level when you are too busy with too many academic and administrative tasks. Really so privileged to hear you, sir. So as sir mentioned already, 5G is going to take us leapfrog from current scenario where thanks to all the networks till now, we don't have disruptions. And if there are disruptions, so I've duplicated my system at least as a presenter, there should not be a single point of failure. I have two machines running, and so it's good. So sir took us to the journey of 5G, then beyond 5G, and also spoke about several satellite communications and how they're all connected. And so at this point of time, would like to take this opportunity to thank the IEEE Computational Intelligence Society and all the organizers at UVCE and UVC University itself for giving this opportunity. Thank you so much. So this is the title of the presentation. So research and development opportunities in 5th generation wireless and beyond 5th generation, obviously leading towards the 6th generation. And 6th generation has become a topic of all the new conferences that are being planned now, because almost a decade hence we have been talking about 5G. But at least in principle, as Dr. Venugopal said, already in China, Singapore, Australia, America too, and many other parts of the world, Korea, 5G is being already deployed, and they are using it for connected cars. Sir spoke about vehicle to person, person to vehicle, vehicle to vehicle, and connected vehicles. And now also Sir spoke about lighter than air UAVs and heavier than air UAVs. So that's what is the next. Actually, next generation of the mobility is a three-dimensional vertical mobility, where we have the context of the 6th generation wireless would be more and more focused on how the terrestrial technologies and non-terrestrial technologies will have inseparably interwoven modus operandi as we go forward. So I would like to actually address this mostly to the students in my class. I would first of all advise them to take a look at all the recorded speeches of IEEE. IEEE is doing recently, especially on wireless. There was a ComSoc 5 days of workshop. All the recorded speeches are available to all the IEEE attendees. Non-IEEE, I encourage you to become students of IEEE. And so research and development opportunities are plenty. In fact, as we speak, people already from last 4 or 5 years, India and the world started doing smart cities. And so we talk about IoT. Sir spoke about several flavors of it, and the fact that energy for an IoT device is 10 years. For a mobile device, still we are not yet there of 10 years, but for an IoT device, yes, because they consume less power. So mobile device, because you have a lot of apps, we might extend the life, but still the mobiles need to be recharged for a good reason, that you keep the phone away when you sleep. So away 20 feet or beyond, plugged in. More efficient versions of the smart solutions for smart cities, smart villages, as we speak. In 10 years from now, we no longer talk about smart cities, but we will be talking about smart agriculture, precision farming, using tools like UAV, agriculture. In fact, I am supposed to be also in a conference where there is a agricultural UAV thing, and right now I am in this particular program, so I could not be in both the places at the same time. So smart grid, smart energy metering. Power and Energy Society focuses on how to make our electrical grids or microgrids such are evolving with solar and wind energies, and how do we account for their contribution to the network by smart energy metering. In Delhi, there is a Energy Efficiency Systems Limited, which is going to distribute their meters to all the electrical departments across the nation. And sir spoke about industrial IoT, and there is a typo there, industry 4.0, industry 5.0, where a lot of automation, robotics is there in manufacturing, intelligent manufacturing, and robotic process automation, and three-dimensional printing, which is otherwise known as additive manufacturing. Some of the attendees are also from Factory.io, which is a company that is focused on intelligent manufacturing. By putting to use all these insights that you get from 5G like wireless, 5G or its predecessor 4G, or even before that 3G, 2G, we still have in the world GSM, CDMA as we speak. So any of the wireless inputs plus the insights coming from CNC machines and the PLCs and the environment, that the ERPs, MRPs that we have, and also IT solutions for HR and other things combined together to take intelligent decisions for manufacturing. So these are some of the kind of opportunities for students to look at broadly. Initially, when you pick up any subject matter, go at a T kind of thing, learn various technologies. Let's say, what is 5G technology? What are all the previous technologies like 4G, 3G, 2G, our first generation? Then talk about flying machines. Human beings have already completed 100 years and beyond after the Wright brothers in Cincinnati, Ohio. And satellite communication, India is one of the pioneers in along with NASA and European Space Agency. So ISRO is there. You have high altitude platform systems that Dr. Venugopal sir spoke about. So deep dive into big data. So a lot of information is there about how the data is transforming, and the data is contributed by GAFAMs of the world. GAFAMs is Google, Apple, Alphabet, and Amazon, Facebook, and Microsoft, the social networking giants. Social networking, mobility, analytics, and cloud are transforming the way that we consume data, generate data, and also there are norms around the data like GDPR and privacy norms. And India is leading in the research of data security by instituting a department known as Data Security Council of India, headed by a lady in New Delhi. And the cloud and the open source tools. There are many open source tools I would mention during my talk, including Linux Foundation driven native cloud native networking foundation, plus Linux Edge tools which the student community can access. With my 30 plus years as I spent, I could actually physically meet these Linux Foundation gurus, and they are happy to share their Edge OS to any of the research community. And I met them in forums like Open Daylight, and also at Derby Center of the another education institution, and also the Indus entrepreneurs. We invited them to give talk about Linux Edge OS, and that is accessible if some students want to lay their hands on and get access to some of the blueprints which you can directly reuse in your projects. So instead of reinventing the wheel. So basically, as a student or a researcher, you have to have a collaborative approach, like what is CIS doing, like IEEE Computational Intelligence Society, or what computers department is doing, or CompSoc is doing, or even robotics or aeronautical and electronics, AESS and information systems, control and other systems teams. Similarly, there are so many avenues, including Dream 2.0, Dare to Dream by the Sir APJ Abdul Kalam's, in memory of him. We have currently, as I speak, last evening at New Delhi, there is a Vaibhav, that is a conglomeration of global experts on what are all the technologies, emerging technologies that may be of useful for India, what India needs to do. That as is happening, it will happen throughout October. And I encourage you to keep your ears and eyes open to information in those areas. Similarly, if you are one of the researchers aiming to start up, India is a good place to do startup, especially if you are in Bangalore, anywhere else in the world as well. And MSMEs and incubation cells, you associate with one of the centers of excellence and you will be given support. And if you have got interest in doing some internships or long-term projects with MTech through your faculty, please get in touch with us. We'll try to see the match between your interests and what we do. So basically the difference between any stumbling block, as for example, COVID-19 today, and stepping stone is how we want to use a bad to good. In fact, some experts say that never waste a disaster. Anything that you get a failure, never waste a failure. It's a golden gift God has given you, and utilize it to the fullest, because it is the otherwise you won't see the kind of that particular angle of you, or you will not realize certain things. So better that the early you get failure in your implementation, the better it is for you to solve the problem. So the journey of 1,000 miles begins with a single step. So don't just sit there and keep criticizing, oh, world has stopped COVID-19 and there is now nihilism, world will stop. No, it won't stop. World started 14.5 billion years ago, and a planet Earth around 4.5 or 5 billion ago, and humans a few millions of years. Living creatures existed prior to us, and that is one of the things is COVID-19 is one of the microorganisms which is not in control of humans, is starting to evolve. It is also undergoing its own evolutionary journey. So basically, let us come back to our wireless evolutions. So it all started in America, while rest of the world was having other approaches. Something known as advanced mobile phone system. That was a 30 kilohertz phone, and if once that 30 kilohertz is given to somebody, it will remain with that person. God gave us 24 hours a day, which is 1440 minutes. That 30 kilohertz is completely dedicated to one person. Huge allocation of resource. And as a normal human being in those days of, I'm talking about 1980s and before, the appetite to make phone calls may be restricted to 5 or 6 phone calls a day, or receiving 5 or 6 phone calls a day. Together 12 times you are using the device, but rest of the entire 1400 minutes, let us say you used it for 40 minutes a day, remaining 1400 minutes, the huge waste of resources allocated to one person. Therefore, frequency division multiple access, which was the principle of 30 kilohertz amps, has transformed by adding another dimension of time division into it. And there, as America started to look at the TDMA in Europe, GSM has started to pick up momentum. And during 90s, the GSM became the world famous wireless standard. And interestingly, even till date, that is being used because of one great feature that GSM came is an international roaming capabilities. And again, going back to America, CDMA technology became popular in US thanks to 3 or 4 contributing scientists and mathematicians who never knew that their research is contributing to the development of this technology. Couple of them, they are mathematics professors, Walsh and Hedemard. They set out a task of generating the number sequence of, let us say, 64 zeros and ones. They developed a matrix ultimately, and their idea was to develop orthogonal number sequence, meaning that when you do correlations, autocorrelation will be maximum and cross correlation will be 0. And indirectly, they helped the wireless industry to have high correlation between the communicating devices and cancelling the noise, and therefore it was effective fit for the spread spectrum technology that came interestingly through another interesting story. There is a lady, Hedy Lamarr, who was the wife of a Czechoslovakian army officer, happily serving the guests of her husband, and those brilliant young engineer fighter army personnel listening to the strategy from her husband. And he was talking about changing frequency, in technical words, hopping, frequency hopping, and then making the enemy not to guess, that is randomness, and spread spectrum. Eventually that was what he was conveying to them, so that enemy cannot notice your signal, but you can see because of your spread spectrum technologies. So there was a reason why she had to leave him, because of her profession, and not a personal reason. Her profession was more important than her personal life. So she settles in America. She was also a beautiful actress. And then she was, after shooting, she was very quiet, not interacting with other members of a movie industry. So one music composer asked her, okay, I know about you a little bit, tell me more about your husband. And after her conversation, they both walk into a patent office, and that guy, God has gifted him a great skill of writing, like how your certificate of your master's or your engineering look like, calligraphy. His handwriting, he has ability to write so fast, running script as if it is printed by a machine. And they wrote 13 pages in black ink and went and filed their patent. And that single document became the mother of all the documents pertaining to all the wireless research that happened in the human history, including Bluetooth, Wi-Fi, Zigbee, and all the IoT that we talk about today has come from her patent, Hedy Lamarr. Her son runs a charity. He is still alive, and she's no more. And I encourage you to go and look up in Wikipedia about them. And then the evolution of CDMA became EVDO, evolved data optimized architecture, which is for applications for pure data, which is similar to LTE data. And then during 2008, LTE took over after the WiMAX failed because of peak to average power ratio performance, thanks to discrete Fourier transform in the uplink, which made the uplink as single carrier FDMA. See, LTE was chosen by 3GPP as the standard to go, and WiMAX faded off and restricted to only point-to-point microwave towers, not for mobility as a mobile as you use in your hands. And then the 5G new radio discussions happened from the release 13, 14, 15 onwards. 5G wireless has picked up momentum. 2015 onwards, people started talking about what is next after 3G, and LTE was there. And what is next after LTE? There were a lot of improvements of LTE. LTE was based on OFDM, orthogonal frequency division multiple access. I go back to first generation, it was FDMA. Second generation, FDMA plus TDMA. Third generation, on the one hand, it was code division multiple access. On the other hand, it is a combination of FDMA and TDMA that was done in Europe. So Europe was doing GSM, while America was doing code division multiple access. And then afterwards, LTE has chosen orthogonal frequency division multiple access. It is like taking 20 megahertz spectrum. You take 1 megahertz on both extremes as guard band, leave 18 megahertz, divide by 1200. Each one piece is known as a subcarrier of 15 kilohertz, and that is a sinusoidal wave. And the concept of orthogonal frequency division multiple access is right on the peak of the curve. Sine wave will have a peak and then again a valley. And if you are riding on the peaks, you will have multiple activities can be assigned to these sine waves. 1199 other sine waves as one sine wave is doing a task. So divide a task into different sine waves, assign them and combine them. That is how you do orthogonal frequency division multiplexing, similar to massive parallel computing paradigm in computer industry. And then now what we talk about sixth generation. So the fifth generation wireless has adopted OFDM. One flavor of OFDM is known as a filter bank OFDM. And sixth generation air interface standard is not yet frozen. After 5G is fully deployed, mankind will resolve how the air interface of 6G should look like. And until then, the 5G's evolutions will keep happening. And then I would like to say why this ISRO is interested in 5G. There is something that they have done recently that is known as the Indian Consortium, a constellation for navigation. A set of satellites, some of them are geostationary Earth orbits. Sir spoke about it, Dr. Venugopal sir. And then there is also LEO Earth, low Earth orbit satellites. Some of them are 36,000 kilometers. Another is at a 2,000 kilometers, and in between is a 20,000 kilometers. That is for the medium Earth orbit. But NAVIC has more about combination of geostationary and some are LEO, and spreading to all over India and also its borders. So this is suitable for all the implementations of the networks that are running in India, including national timing system, and to synchronize all the systems, including our clock that are used by radio, television. Sir also spoke about satellite communication and also how a television and a cinema picture and a persistence and latency and delays and errors. So these are all the areas for you to work: 5G, IoT, cyber security, ciphering, deciphering, encryption, decryption, and smart cities, smart village, industrial IoT, artificial intelligence, cloud computing, and how to implement them. These are all the research opportunities to go further. So when I say about all this, you might think that, okay, you speak several things, but can you just come down a little bit and tell me, can I touch and feel who are doing these things? Yes. Initially, when we talk about wireless, there are different stakeholders. One is technology providers who give you field programmable gateway and ASICs, like sir mentioned about nanotechnology. We have a center of excellence for nanotechnology in the premises of IISc, and also one in Mysore and another in Chandigarh. And Texas Instruments, Qualcomm, Broadcom, there was a talk about a merger between these two and did not happen. Similarly, ST Microelectronics, Analog Devices, and so many others. And Intel also, and Cisco as well. Many of them are into this. And OEMs, Nokia, Ericsson, Samsung, Cisco, Sienta, Juniper Networks, etc. They are the original equipment manufacturers who take the technology that is provided by the technology providers when they make the product. And then we have telcos, that the communication service providers like Vodafone, Airtel, Reliance, Verizon Wireless, AT&T, T-Mobile, and a host of others like Etisalat in UAE, and a number of other like telecom networks in Namibia or Globacom, several other telecom providers. And then we have the content providers typically coming from social networks like Google, Apple, Amazon, and of course Alphabet is also Google, and Facebook, and Microsoft. These are some of the social networking giants which will provide you content. Cloud providers are IBM Cloud, we have Google Cloud, of course, Microsoft Cloud, Dell, and NetApp. These are some of the, and then there's a Data Samudra, which is coming up near International Airport for those of you in Bangalore. So data centers are there, and there is a NTN. So there is a TN and NTN integration, and handovers are taking place, and especially 3D networking is evolving. Therefore, you will have opportunities to play a role as a developer of solutions between the terrestrial networking systems and non-terrestrial networking systems. A huge business opportunity for you in coming few years. Similarly, internet service providers like Hurricane Electric, and in India we have a digital sky platform by Directorate General of Civil Aviation, where they are giving some APIs which the students can access and integrate into their applications, and then showcase their results, which government may want to encourage them by giving award and compensating for their efforts. So before beginning the work, talk to the professors and write to DGCA, and it would be helpful because they are also trying to evolve their digital sky with all those APIs that they kept publicly open. And write to us, we will also guide you. So communication service providers are also specially coming up for how to manage the UAVs, special new front is evolving. So normally telcos are too busy with our phones and call drops. And for UAV, there is a niche area of specialization and focused on their requirements. There is a need to evolve this segment called communication service providers dedicated for the UAVs that is evolving, as I say. So we are all here for some special reason, as Robin Sharma says, and don't be pessimistic and stop being a prisoner of your past. Become an architect of your future. That's what is Robin Sharma. My daughter, who is an MD, she keeps following his speeches and reads his books. So this launch pad is, I would ask you to get in touch with us if you want 1 year of a free license of production quality of some of the license keys, which like I can talk about MATLAB license keys. And there is a person, Partha Patnaik, and there is also his colleague, MS, will get you the license keys. Your company, your startup company associated with, let us say, an engineering college needs 10 licenses or 20, write to us. We will get you. And similarly, I already mentioned about Linux Foundation, their Edge OS also we will get you arranged without paying money. So what are the data sets that we need to handle? Sir spoke about Tenenbaum, and then he said the communication systems are leading compared to computational systems. So when you talk about data sets, there is something called data, and then there is a software, and then there are certain people who release that information systems into the public domain, like internet, and they are supported by servers. There are some internal servers like on premises, another is in the cloud, and other storage devices. And there are so many IEEE documents and publications which you don't get it openly in Google search. So you have to pay for that. So the data sets are all managed by certain stakeholders. You should know where are all these repositories, like library network is there for universities to access to. And there is also community maintained repositories, like say, if you are in a Bureau of Indian Standards, all your data relating to standards is available and open also for public, because 20,000 standards that India has so far developed, they are all meant for any citizen of India to access it. And if you want any BIS standard, write to us. Vidya Sangha will get you the copy of it if you don't know how to access it. And cloud. These are all the providers or the systems where data sets are managed. So basically, what is the kind of a context of managing the 5G and beyond 5G and NTN is, apart from the physics, which is done by the very technology foundational aspects of it, as a computational or as an engineering student, where is that information that you can access? Certainly not making the chipsets, because it will become too much like a electronic subject matter like VLSI design. We are not going to discuss that. We are talking about data. So all these technologies like 5G and beyond 5G and NTN generates a lot of data. Those data sets need to be managed. For that, you need to have when you develop a code, you first of all survey literature about what are the metadata about the subject you are writing, and you write a language that is commensurate with others to do interoperability testing. And sir also spoke about IoT. The one of the IoT is not just Internet of Things. There is another definition called intelligence of things, and another third definition is interoperability and testing. So metadata helps you to help whatever code that you develop as one engineering college, and how does that code work with another code written by another engineering college, and can there be a commonality in them? So that is what is extending your metadata. And publish and subscribe. So you can publish your data and others can subscribe to it rather than reinventing the wheel. That is how the IoT platforms are looking at solving the need for developing too much of a code by everybody. So specialized metadata are there, data, special meta, special and software for publications also. How do you publish your metadata? There is some norms around it. Similarly, there is also minimum metadata you need to have for some devices at a mediation level. And for which, for example, in India, we have a research firm of Government of India known as CDOT. They are developing 1M2M middleware, and they will give you the scriptures which you can use it in your coding. So they are helping the smart city industry and other IoT industry by giving a common minimum mediation layer middleware, so that all the devices can speak same language. And so that is what is the need of the hour. And primary digital objects, basically data that you get from sensors. Sir also spoke about a lot of sensors: temperature sensor, you have got a humidity sensor, mobility sensor, all that they speak the data in their own niche way. And two devices from two different products, they may not match with each other. There was a famous air crash, one built by Americans, another by Europe. After the crash, investigation revealed, without proper discussion, some team calculated based on RMSA device tool, and others based on foot, pounds, and second. And therefore, definitely the number numerically they were talking in common discussion, but not about units they were talking about. And the spacecraft collapsed. Therefore, even at a macro level, such errors take place. Therefore, we should be careful about when you write a code, you articulate it and make sure that others are also follow what you do, so that your work can be reused by others. So basically, what are the problems to pick up for 5G, beyond 5G and NTN? One is how to optimize my cost and boost my productivity. Suppose I have a lot of infrastructure. I am a telecom company. I now have to invest on 5G. How do I do that? I need to save on something. So if you can save on existing 2G, 3G, 4G infrastructure, that saving can be invested for developing the 5G infrastructure. That is one of the challenges your solution should provide. Similarly, make it more intelligent. Today's telecom networks are not that much intelligent. And you have to make manufacturing operations also intelligent. I came to know that more than for voice, video, and data, applications of use of wireless technologies for taking intelligent decisions for higher end manufacturing, where your production is of more than 50 crores turnover and such things. That is where the technology is more useful, because a small error taken by human misjudgment will cost on the product quality. Therefore, leave it to the wireless, which is having low latency and high bandwidth, and more intelligent insights you can get, and actionable insights from the SCADA and other sensors and IoT, and take timely action to prevent waste of your materials of low quality because of certain onboard diagnostics or on some equipment right now. For example, ABB gives you a handset, and that can detect vibrations of a device. Earlier days, they used to put a hand and feel if there is a problem in the device, but ABB handset can solve it. And so the modern techniques will solve issues better than the existing solutions. Similarly, you need to have a quick reaction solutions where you use ultra low latency and reliable communications, and avoid multimedia broadband communications, and you have got a massive machine type communications and seamless interconnectivity and cognitive radio and spectrum intelligent handovers. All these are the areas that you can pick up to solve during your work. So basically, I wish to throw some light on the subject matter of this IEEE book that I referred. There is a world forum. I'm going to give you practice of how to get in and look at all the proceedings. Only this year it has been made available as a multimedia, which you can refer it until 10th of October. And here is a satellite, which is obviously non-terrestrial network, talking to the G node B. So it is like a UE, user equipment. So this geo satellite behaves like a user equipment to the G node B, which is a mother Earth station, and then that is feeding to the core network, and then you have a terrestrial network also. So there is a interaction between the terrestrial network, which is on the 2 dimensions, and the third dimension, vertical dimension, that is the satellite communication, and there is a common link between these two, which is a G node B, wireless 5G base station. And we are doing studies in IEEE, known as IEEE 1931.1 Edge Roof, which is a real-time operational on-site facilitation. And we have Shyam, who is right now in US, and other members like Nishant, myself, Dr. Ambika, who is in industry now. Earlier, she was a professor in Kristu Jayanti. So there's so many others in the team, and you can work with us in evolving that PAR approved standard about roof computing, which is similar to fog computing, or what the popularly known as a edge computing. So the table in this visual talks about subcarrier spacing. I gave a calculation of 20 megahertz divided by removing 2 megahertz, 18 megahertz divided by 1200, which is the subcarriers. 15 kilohertz is the subcarrier spacing for normal LTE. On that, in case of 5G, they have taken 30 kilohertz, 60 kilohertz, and 120 kilohertz, even beyond, which is not in this table. There is also 400 kilohertz possible. And then you will get bandwidths. Sir mentioned also higher bandwidths like 10 gigabits per second. So, and then there is also the chip sets. I mentioned there is a Qualcomm, Broadcom like companies which make the chipsets. So those, when they make a chipset, it is like the chirping. Within a 1 millisecond, it will generate some symbols like 14 symbols. And so in 1 second, 14,000 symbols are coming out, and multiplied by 1200 subcarriers, and each of that symbol will have 8 bits in it. Therefore, 1200 into this 14,000 multiplied by 6 is 100 Mbps. That is what is LTE technology. Later on, that multiple carriers of LTE and multiple antennas, MIMO, and coordinated multi-point are the new features that came up on top of it before stepping into 5G. And in this page, we have a comparison of traditional 4th generation wireless network to what is happening in the 5th generation. So we have got we have a PDCP, RLC, MAC, and 5 layer, and that has become in the core from the different configurations exist in implementing them, and you can look through. So I wish to go further too. So here is the 3GPP. I'll give you a walkthrough how to access these reference guides. As Dr. Venugopal sir said, there's a Tenenbaum book for computers. Then for wireless, where is that kind of a Tenenbaum? And that is 3gpp.org. And I'll give you how to access it. And those of you who are already having internet access right now as I speak, go and check for something called Dyna report. And the second keyword in the slide, and then space the first bullet point, release 15. First you type that, and then it will give you a set of documents. Later on, you can ask same for other releases also. Currently, release 16, 17, some parts of them are being updated. Release 15 is already completely available by 2020 itself, and even before, but some more additions are being written. So we have a 5G quality of service model. Basically, what is meant by quality of service? Typically, in a service, for example, I give example of a courier agency. Suppose we have a box or a paper, an envelope has to be sent from one place to another. So you can put it in a postal department, write the address, it will reach. But that is known as a best effort delivery. Unfortunately, in the language of quality of service, best effort does not mean in literal meaning of the word best effort. I will do my best. This is not the meaning. Best effort means no QoS. But then there is another way that you can do. You can go to the postal department, ask for a speed post or registered with acknowledgement due. This is one way of ensuring that guarantee of delivery. But you also want a speed of delivery. Then you may want to go for a DTDC or much more quality. If you want, you go to Blue Dot or Federal Express. So each of these courier agencies will charge you differently. So similarly, quality of service, depending on the kind of services that you take, you will have a different payment subscription you have to do with the service provider. Technically, how it is implemented, you take 6 bits. 2 raised to the power of 6 is equal to 64. So if you take 0, 6 times you write 0, and then all the way down up to 6 times you write once. In between, you will have that 62 values in between. Totally 64 values. So in between, you generate some code and say 42nd value is my best effort. This indicates best effort quality of service. And then similarly assign for assured forwarding and expedited forwarding, depending on, as I gave example of Speed Post, DTDC, Federal Express, and Blue Dot. You will have different levels of assured forwarding and different levels of expedited forwarding. So all these are known as different flows of quality of service, as you see in this visual. One is known as a quality of service flow ID1, which is 4. Another is ID is 6, ID 7. Like that, these are all assigned with right from the user equipment to the G node B, which is the name given to the base station of 5G. There is a radio bearer, and then as it passes through the core, there is a packet data unit session, and there is a access and mobility function, service management function, user function, user plane function, and these are all the different components of a core network. And there is that SDF1, SDF2, SDF4. These are all the service data flow assignments that are happening in the 5G network implementation. So quality of service is a simple thumb rule of 80-20 rule. That means that 20% of the consumers of any service will be paying 80% that particular provider gets. This is called 80-20 rule. And remaining 20% revenue they get is from the remaining 80% of the people. But still both are required. You have to treat them equally, because only in California, Orange County, you will find Bill Gates and Warren Buffett. But just because of those two, that a service provider should not ignore the remaining 80% of the American population. They have to serve both communities. And the risk of serving high profile client is that if you make one small mistake, they may cancel the order to you. You lose that entire 80% money. And then if you don't have the backup, the 20% community which they are not serving you, you will become bankrupt immediately. Therefore, you have to serve the quality of service customers. At the same time, try your best to give them the quality that the highly paying quality of service consumer, if they are not consuming the resources, you give that much quality to the normal users so that they will be loyal to your network. That is the secret of doing the wireless network or any other service. Like say you have an aircraft, your first class or a business is completely vacant. So why do you congest people there? Take 10 people from the economy class, fill them in the business and first class. Then you are not only evening the load on your staff, and you are making them feel good, and then next time they will become your business customers. They talk about your airline so happily. So that is how you have to provide a delight to end customers. So this is what I mentioned about what you will get from the Linux Foundation. This is the link, LF Edge or Projects Archino. This is the place where all the blueprints for your research work, they've already written the code, and they are generous to give it open for everyone, and using that, which is completely edited and updated. And there are so many committeds, lot of software professionals ensure that that is current with the requirements of the mankind today. So you can use that already available code and then run your code and then develop a solution. Don't have to reinvent the wheel and then have to worry, oh, I don't know this wireless industry, I can't work in the industry. No, you don't need to worry about it. I also kept the diagram of a traditional wireless network architecture in the language of the cellular architecture, which is a hexagonal architecture that is there. So just imagine for a while the central hexagon, there is a power failure in the tower. So what would happen? All the neighboring 6 towers, their access will come to you, but there will be something known as a pilot pollution. So at the central point, when the existing tower is unable to serve, the mobiles will experience too much of a pilot pollution, in the sense that you are accessing to one, but again you are disconnected and accessing to others, and you need to manage the dynamics. That is what is your challenge. So the solution is ensure why the central one is failing, make sure it will come up quickly so that it will handle the local customers without worry of all the remaining 6 pilots. So that pilot pollution can be solved by making the local pilots stronger. So these are some of the principles of wireless. And I kept some parameters like terrestrial cells. Imagine there are some 7 terrestrial cells. And so this is what, and then there is a power is measured in a decibel compared to milliwatts, dBm. And some sir already spoke about gigabits per second. And so these are some of the terminology that is used. On the right side, I said in this month, these guys started a new company. Whenever you do a project, remember, if you go to IBM or Cisco or any other cloud, they have fixed pricing model. I don't discourage you, but you can actually try the new ones because they may give you 1 year for free because they just want to eager to establish their presence. Or you can also try other governmental data centers, such as those available from CDAC. Government of India is having this, as sir mentioned about a nanotechnology. Government has another technology in India that is known as National Supercomputing Mission, with which 6,000 crores are already spent to build up this kind of center, as you see here, in 70 different locations in India and under the umbrella of CDAC. And so if you really genuinely have a program which deals with weather or maybe COVID-19 analytics, you know that when the early stage of COVID-19, the worldwide governments have taken support of Google and Apple, assuming the user is either having an Apple phone or an Android phone, and they are actually able to do analytics of who traveled in a plane, and if he was supposed to be a COVID patient, what is the possibility of others neighboring to him? Imagine that those days there was no personal protective equipment available. So how do you reach out to them and check their health and to avoid the spread of the virus? All that is already, even now, Google as well as Apple and other wireless network providers, they have all the information about us. And Government of India also has that app that helps us to overcome these difficulties. Arogya Setu app. So metadata. So people who are crazy enough to think that they can change the world, but don't criticize them. In fact, they are the ones really who can change the world. They may be crazy, but the change makers, they look like cranky to you, but you should be one of them, at least in your mind. So metadata is that is helpful for coordinated innovation. I mentioned about a CDOT and also proof of concept, prototyping, go to market. So as a manufacturer, you need to supply something to a OEM. You may be a tier 1, tier 2, tier 3 supplier. You need to have the quality processes and metadata knowledge and follow what, for example, in India, IoT, you go with one M2M and a CDOT being a government R&D, follow them. Then you should be able to supply to, say, ITI when they manufacture 4G or 5G base stations. So big data nomenclature beyond the databases. We have got something called interoperability testing, I mentioned. Another is DigiCash. Government of India allows you to transact between the, say, using Beam like apps. Multiple payment gateways are integrated, and you can think about a UAV traveling for some distance. Suddenly, as you travel, you get tired, bro. So imagine you are traveling in a forest-like area, and there's a tree, banyan tree, and there's a shade underneath. You would like to rest there for a while. So that is how our ancestors used to travel across the cities. They didn't have motor vehicles, or they used to travel for months together across the nation. So DigiCash, I want to take that analogy. Let us say there is a UAV and it is traveling and it got tired. Somehow its battery became weak, and it is intelligent about the battery becoming weak. So it has to rest somewhere. So that is known as perching. So it will now call for help. Either its battery need to be recharged or something snag has happened. So it will call for help, and some help reaches there. And without waiting for the master, because the UAV has already traveled away from the launching place, it can settle the payment using the digital currency wallet, and it can complete the transaction and fly back again. And something like a crow, when it is when it is thirsty, it put small pebbles on a small pot, and water came up, it drank and ran away. Similar to that, a UAV can be like a crow, and it can use this concept of digital cash, digital wallets, and perching. Perching is an idea that is popularized by Scientific American by emulating how many birds make their nests on the branches of the trees. So UAV's parking area can be like a perching area for the birds, and automatic payment across multiple devices and artificial intelligent bots enablement. Dr. Venugopal sir already mentioned about the language that you speak, the machine will understand, and there may be multiple devices attached to your body like your face or eyes or heart. So there is a language driven controls also possible. So Data Samudra, why I am taking is I went through their presentation. So these are the attributes that you will get, and I would like to bring to your attention that in India, luckily, until the 3G days, there was no standards development body in India. Though there are so many companies which are developing and participating in international standard bodies like IEEE, 3GPP, and ITU. But India, we have got a telecommunication standards development body has formed under Madam Pamela Kumar, Director General. Team is formed, a high level apex body has been formed by Government of India, Dr. Paul Rajan Aragaswamy, who is a co-founder of a MIMO concepts for the whole world as an inventor. And he is advisor to the government, and they are recommending use of 5G for in the phase 3 for the UAVs for navigational purposes. That would happen in a couple of years, as Dr. Venugopal sir said. In 2-3 years, it will come to India, and you would be requiring to use this kind of data samudra for parking your data and retrieving it, and also you require support of the standards bodies to implement your solutions. So basically, true happiness involves full use of one's power and talent. That's Gartner says. So basically, 5G startup opportunities, what are they? I talk about design development opportunities. I have I know about a company that makes the 5G from scratch. That's a startup, Bangalore based, and I can connect them with you for you to do some projects or internships. And there is a ESDM cluster is evolving in Bangalore under umbrella of ITI. And then there is a 4G, 5G indigenization efforts of ITI, BSNL. Tech Mahindra made an announcement recently that India will manufacture 4G, 5G by ITI. CDOT and being a R&D team of BSNL will also get the business opportunities there. Department of Telecom, CDAC, as I mentioned, for National Supercomputing Mission. Similarly, for doing conformance testing, when you made a UE and there is a G node B, how do they communicate with each other in terms of the ITU or a 3GPP specifications? Dr. Naveen Kumar of Amrita has undertaken that kind of a independent study of conformance of all our specifications, whether really on the ground with that specification the products are behaving or not. He has done studies there. And similarly, there is research opportunities with the Department of Science and Technology, Ministry of Electronics, Information Technology. And there is also new opportunity, especially from 5G, to do new business models of 5G. Earlier days for 4G, it was not possible to have small players to play, but from 5G, there is a private 5G possibility is there. Therefore, a particular community can have its own, like a small radio station for yourself. You can have a private 5G network for yourself. That is possible. And with the advent of the virtual private operators, virtual mobile network operators, and several IITs and IISc and Government of India has made a 5G testbed. Studies are going on. Similarly, DRDO has a extramural research and intellectual property related funding opportunities are there. And in Bangalore, for example, we have got something called Arisent, and it became Atran. They are pioneers in the middle, that connectivity like photons, as Dr. Venugopal sir said about the photonics and fiber optics and terahertz. And so eCPRI and MCOD. COD stands for Central Office Re-architected as a Data Center. That is a proof of concept done by Alcatel-Lucent equipment by Stanford University. And further to that, as a new evolution of that CPRI, it is not Central Power Research Institute of Bangalore near IISc. It is that is a common public radio interface. It is an interface name in 5G and the evolution of that. These are all some of the areas where you can do research. Similarly, 5G brings up opportunities in beam forming. You can have a specific phased array, and the antenna may be focusing on one device by forming a beam, and uplink can be on one kind of a beam forming strategy, downlink can be on another spectrum and another antenna strategy, and you can have a massive MIMO. And added to these paradigms, we have new things which are coming from computer industry into the wireless. That is actually a welcome for the wireless industry. That is artificial intelligence, deep learning, reinforced learning, machine learning algorithms. That is based on convolutional neural networks and RNN. And how do you reuse a frequency which was hitherto used for GSM or CDMA for 5G or 6G, that is called spectrum reforming. And similarly, we'll have defense applications or drone computing. And similarly, there is a production linked incentive schemes are there. If anybody wants to enter into manufacturing of mobile phones, this is the right time to do, because government has a production linked incentive schemes. And you can also use techniques like adaptive learning methods for industrial IoT, IoT 3.0. IoT is evolving itself. Internet of Things has become intelligence of things, and then the interactive intelligence of things between devices. That is a 3.0, and this is the evolutionary path. Similarly, C.1M2M I mentioned, and this is the place to look at for tapping into their work. It is their official website. And now switching gears to non-terrestrial network. So when somebody says they are talking about non-terrestrial networks, Dr. Venugopal sir rightly pointed you to the aeroplanes, the UAVs and the satellites, and that's what is about it. And then he also mentioned about the high altitude platforms, and there is a project of Google and Facebook. Loon is one of them, and there is a tethered UAV. Tethered UAV is, imagine there is a UAV which is continuously powered for more than a day. Normally, there is a constraint of power. If it is battery driven, battery will have a longevity of certain minutes or an hour. But if you want a UAV to sustain for weeks, months, then you can have a wire from the ground and have such a long wire that it will power it. And when provided there is no movement of UAV, which is static, but it is looking down and serving a locality, something similar to Philippines or Indonesian islands, where internet access can be given by the UAV. And that is one of the ways that tethered UAVs can perform. So this is the kind of a reality picture of what this topic of today. At the ground, we have a green the landscapes and mountain. And in the bottom left, you find the terrestrial networks, lot of buildings and towers and wireless infrastructure as we roam about in the cities like Bangalore, Mumbai, Delhi, like that. And thanks to 3G, 4G, this is their slide. And then we have the satellites at a level of 30,000 plus kilometers, known as a geostationary Earth orbit, and LEO, which is actually 2,000 kilometers. Anywhere from 100 kilometers to 2,000 kilometers, there is a LEO Earth orbit. In between is the MEO, and mostly we focus on GEO and LEO for our non-terrestrial networking at the moment. And then the aircraft will normally don't fly about 10 kilometers. It is written typically 9 to 11.5 kilometers. So this is the game plan, and currently they have been all different. Satellites are managed separately, air traffic is managed independently, and terrestrial networks are so far independent. But then there is now interconnection between them, and there is a lot of new evolutions taking place in integrated airspace for the civilian traffic as well as UAVs. Similarly, satellite and terrestrial networks based solutions. For some examples I gave, providing internet access to remote areas, and to do certain other missions where UAV needs to be in the air for more than 7 days. Then you use a lot of satellite support to also know the location of the satellite. There is a phenomenon in UAV known as ADS-B, that is autonomous dependent surveillance broadcast, which will help. Like there was a unfortunate incidence of Malaysian Airways MH370. People did not even now discover where it fell down and whether it fell into ocean or not, also confusion. But now with this new concept of ADS-B, which is a tactical collision avoidance system, or a identification friend or a foe like messaging, that is ADS-B, which is mandated every 15 minutes. A flying object has to inform to satellite and ground-based systems about its changing locations, latitude, longitude, velocity, altitude. So this is the digital sky I mentioned. Government of India is developing a digital sky, and this is the link where you can tap into the APIs I made a mention about, and work on developing. Using those APIs, you can develop some solutions, and those solutions are: how do you help the UAV traffic management given the opportunity of 5G, and then beyond 5G and non-terrestrial networks? How do you make sure that this entire traffic of UAVs and civilian aircrafts and terrestrial ground-based cars and mobile users, how all these systems work together toward their common benefits? Some of the attributes are given. UAVs can glow up to 50 kilometers. Typically, high altitude platforms which are released by balloons will stay afloat in the air. One of the recorded high altitude atmospheric satellites was there up for more than 4.5 years, just like a tiny little satellite. And that was very helpful to provide services using that. So there is a lot of research going on in that area. I encourage you to look through more in this area to further do research. So Atmosat is a satellite that is launched with a balloon and stays there in the air, which is called Google Loon, 20 kilometers height. Similarly, unmanned drones can be at a 20 to 25 kilometers, which are not the normal drones, but these are heavy, high performance UAVs, which are known as high altitude long endurance or a medium altitude long endurance drones. Typically, currently used for defense applications. Also, very much useful for cargo and other for futuristic urban air mobility, where human beings can also be transported in future. So we have a HAPS mobile 20 kilometers, which is solar panel based. Couple of pilots like Bernard and Christopher went around the world with a solar powered two-seater plane to prove the point that aeroplane can need not use air traffic fuel, and it can sustain on the solar panels and batteries and alternative mechanisms. So similar to the industry of car, where you have got a BMW or Audi or Mitsubishi, there will be new developments of UAVs with hybrid power systems like a battery or a fuel cell, or also internal combustion engines. All these things integrated power systems and intelligent power systems based redundant communication systems based UAVs will evolve in future. And here I would ask attendees to take some time and go to 3GPP, these particular standards. So what you do is you go to 3gpp.org/specs, SPECS/. So you will get, when you say specs, you will get folders. Then you choose the year and month. So 2000. So you will, so when you say specs, you will get in the result 3GPP folders, which are just like in your normal computer, how you are able to access. And you look for this is a way to go. First is you look for the year and month folders, and then choose, let us say 2019 and December. Every 3 months, this 3GPP is updating these documents there. and then go inside that, click that, then it will open up release number 14, 15, 13 like that. And release 15 if you want, go to release 15. Again, you ask for 22 series, all will be placed in one folder. 22, the dot will not be visible to you. 3GPP will not be visible to you, but the file number will be 22261 or 22822 or 22261 as it is in this bold right side. From that, you should be able to pick up the documents of this release. They are all Word files and kept for free. And these are the standards being updated and populated into the 3gpp.org. And the design of the architecture of folders is similar to your FTP on a Windows environment where you can click and then open the folders. Similarly, for the context of our topic of the day, satellite and wireless communication, non-terrestrial, terrestrial, these are the research areas where mandatory features and enhanced features of V1, V2 are being developed during this 2019 first quarter, second quarter, third, fourth, then 2020. We are now into September. So first quarter, second quarter, third quarter, then there's a December will be fourth quarter, and 2021 first quarter, second quarter. So the release 17, it means by middle of next year, all these standards will be developed completely for the NTN and satellite and use case of 5G for satellite. So satellites will start using 5G in their infrastructure rather than currently we have transponders, and the efficiencies are not much. Dr. Venugopal very clearly said highly efficient means in one particular second, using 1 hertz, you can get maximum number of return on investment and the maximum number of data bits you can get on a symbol. And that is in the current standards, 5G is the highest in the world today in terms of 30 bits per second per hertz in a geographical area, and that may become 50 bits in 6G. So this is about collision avoidance, where UAV is also a gateway for mobile access edge compute environment as an ISP system, and it can be helpful for avoiding collisions and ADSB messaging. And Digital Sky, I mentioned there is a platform. I have shown you the link. Similarly, there is a distributed Digital Sky platforms, and there are secure versions for the government. And NIXI, that is the National Internet Exchange of India, to make sure that this data does not leave India and go to the hands of the wrong countries or wrong hands. Because when a collision has to happen, you only have about less than 40 seconds or 50 seconds, and you must make use of these approaches to avoid these collisions. So basically SON, you have this SON and AI for maintenance. SON is in 3G, we have something known as self-organizational networks, and AI is artificial intelligence. So in case of the traditional wireless networks, so we have something called self-organization or a self-optimization network architectures. But then currently with the AI that has been given a boost, so automatic neighbor discovery, which is already developed for 3G, 4G, it will become more intuitive with the AI. It becomes more smarter, and then IP address of IPv6 will be allocated by the SON, and you can also know what has been the trends of it based on predictive and prescriptive diagnostics of a telecom equipment based on last 6 months or 1 year, and what is the operational efficiencies, and then effectively take measures for with the increase of the traffic, how am I going to cope up in future for my requirements of my end users. Mobility robustness optimization, this is the word Ericsson has coined, and if you go to New Delhi, there is Gurgaon and Noida. There are thousands of employees working on global telecom companies, and they are just maintaining their networks sitting in New Delhi, remotely operating their networks. So right now they are shifting from traditional methods of RF engineering to machine learning based and AI based approaches. This is where you have opportunities to do more studies. Algorithms for OSI,
Kishore, I think you went to mute.
Sir, voice is not coming, sir.
Are you able to hear me?
Yes, sir,
Yes,
you're
sir,
not
yes, sir.
audible.
Yes, sir, it's audible.
Yes, sir. We are audible.
It's
Okay,
audible,
fine.
sir.
My network took a recycle. Okay, no problem. Good. So there is something called TAC. That is in case of a wireless industry, there is something known as a technical level, highest level of technical support team, which normally whenever a telecom industry faces a problem, it is called first level maintenance engineer. And then there will be level 2, level 3 engineers who will solve more complex problems. But if the problem is too big, then it has to be escalated to the TAC team. They are the really apex body. They know all the standards. They can rewrite the code. And that kind of job is now done by the AI. AI is also composing music. It is also, AI is also making painting. Similarly, in the telecom industry, it is doing complex jobs like operation, administration, maintenance, and provisioning. And in wireless industry or in telecom industry or in general any industry which requires operations, there is a acronym known as FCAPS, FCAPS. It can be remembered like a feather in the cap. So FCAPS is a fault management, configuration management, accounting management, performance management, and security management. These are the O&M tools that we have. And then there is a TOGAF. There is the next generation OSS and BSS. And these are the frameworks for making sure that the networks are functioning effectively so that end users will not have call drops, etc. So can I, right. So next is the cellular V2X. This is something most happening standard, cellular vehicle to infrastructure CV2X, and that is now going to embrace the third dimension, which is a vertical mobility. So currently there is a two-dimensional aspect which the terrestrial networks have been enjoying, and you can look up more details by asking in Google 3GPP 38.821 or DINA report 38. Then in that you look for 821 series and download that. It will give you the details of this table about characterizing the non-terrestrial networks. So it is a part of the 3GPP standardization, where you talk about how do you hand over a UAV, which is a flying object in the sky, from one telecom service provider, let us say Airtel, to Reliance, or from one tower to another, or from one particular tower is having some users on the ground, some users in the sky. So take out some data from the users on the ground, because it is not that much urgent as compared to sky. So there may be some algorithms to in future which would be standardized. If a air-based consumer needs a service, provide him first, because it is more urgent than the ground-based user. Of course, exceptions may be ground-based user in a connected car scenario. There may be an accident which in the air you can creatively solve it much better than on the ground. It may be a fatal accident. So road accidents are the most fatal human incidents than the corona that you think is the fatal problem in the world. If there is no corona, every day we don't read that news. Every day, many thousands of people in India itself and worldwide, millions of people die. And it's a world's top cause of human death is road accidents. All that can be avoided by effective use of these technologies, so that accident free. There may be one day on the planet Earth when there is no death due to any accident at all. It is possible technically because of connected cars and a cellular V2X and other third dimension that is happening in taking all these steps further. Like DSRC, it means digital short range communication. It is also based on IEEE 802.11p for connecting the devices. And V2P, Dr. Venugopal sir mentioned about vehicle to person, vehicle to infrastructure, and vehicle to vehicle, and UAV to UAV communication. There is, for example, Airbus has created a demo. I'm going to show you how to access the demo. how one UAV can communicate to another UAV. I will show you how that there are animations, and you will enjoy going through that. And this table has intuitive data that you can read through. Okay. So I would further go to where the demos are there. How are we placed? Yes, I think we have some time. This is basically what is the NTN architecture. One is called transparent satellite architecture. Another is regenerative. Another is so basically, what do you mean by that? It means sometimes if there are 3 satellites, let us suppose I am giving some data to one satellite and I have a third satellite. In between, the second satellite will not tamper with the data. It will simply take and pass on to the third satellite. That kind of a system is known as transparent satellite. Regenerative satellite is it will just take the signal and boost the signal and send it back to third satellite. That's a regenerative satellite. That is a difference between transparent and then regenerative. And here is the evolution of LTE, how it has evolved to 5G. In LTE, we have terminology like 4G base station, which is also known as a E node B, evolved base station. It has components like a radio resource unit. I mentioned about CPRI, Central Public Radio Interface, Common Public Radio Interface, and there is a BBU, baseband unit. So combination of the BBU and RRU is known as CPRI. And then there is a EPC, that evolved packet core. Connection between the base station component and packet core is a S1 interface, and that has evolved into the core network. And when it came to 5G, there are changes that are happening in terms of the BBU splitting into the central unit, and another is the distributed unit, and which has a radio components also and a core network. So like this, these are the changes taking place. And as I mentioned, CIPRI is becoming eCIPRI. I mentioned about Ericent and ATRAN doing more studies in that. So the details of that are in the ITU specification, also in the 3GPP specifications. So digital unit and control units, more details are here. I would like to further move ahead because unless you work in this area, it may be too much of a detail, this slide. So this is little better. So basically we have a user equipment and there is a internet. In between we have these wireless networks. The consumers of the wireless network or contributors to the wireless network can be satellites or the non-terrestrial network gateways. And then you got a G node B connecting to the core network on a next generation interface known as a 5G core network. And there is a N6 interface to the internet, that is a World Wide Web, or what we know as the internet. And these are the standards. I already gave you insight on various standards. And so basically these are the standards. The 38.811 gives you more details about the use cases of the IoT and machine-to-machine communications, which are applicable to the subject that we are discussing. And what is the aspirations of human beings for doing all this? You want to help a ship which is the ocean. You know that a team of women candidates, lady officers of Indian Navy went around the planet Earth with very meager resources and very violent ocean, and they finished the trip around the world. And so if you want to make sure such journeys more better, you would need all these satellites monitoring them, and then other ships monitoring them, providing them to support time to time. So this is a evolving subject matter. And how do you make trains, boats, and planes connect to each other? These are some of the aspirations. And similarly, I mentioned about DINA report practice. You go to 3GPP and access this 22 series and open and read. Similarly, 38 series, open and read. If we have time after the question answer time, I can take you through this maybe either on record, otherwise offline. I can show you how to access this. And if you get any stumbling block, you let me know. I can show you on the same session, okay? And this is what I want all of you to practice now. All of you, you open your laptops, desktops, mobiles, take your time, maybe like a 2-3 minutes of tea break, let us say, and just type this out. Make sure you type everything as it is. not my email address. You type out the link first and enter. What it will ask you is, the system will ask you to get into your demonstrations. By the way, what is it all about? It is IEEE World Forum 5G demonstrations area, where I mentioned about Airbus. There are so many other demonstrations worldwide with various subject matters, including the non-terrestrial networks. There is also 5G advanced research, and for manufacturing, and for industrial automation, etc. And our demo is also there. Bangalore-based IEEE has given a few demos, some from Infosys, some from Vidya Sangha. We have a few demos. You log in with I am one of the providers of the demonstration, so I have this login. If you enter this, it will take you. That K is also small casing here. Everything small casing. atkishore@IEEE.org. So it will then you will enter into 16 demonstrations. After my talk, go through all the 16 demonstrations, and also other than demonstrations, you can launch entire program of 5G World Forum. 7 more days. Already registration fee has been collected, so you don't have to feel apologetic of entering like this and enjoying the program. Already program is completed and IEEE got money, so feel free to, as IEEE students, appreciate what a great job done by this IEEE World Forum, and go through all the demos until 10th of October. And you can actually take copies of them wherever you like them. So we are further taking the discussion forward. We are working with a few IITs. One of them is IIT Patna. We are doing hands-on sessions on 5G protocol stack design and implementation from 2nd to 6th November. And you are encouraged to register for it. And this is the small amount that it needs to go to the speakers. Especially we are bringing some dedicated speakers who are not doing anything else than only working on these things. So iSignal Research is one of them. And then since IIT Patna is organizing, the part of your subscription goes to them as well. So I encourage you to register. It is 1,000 rupees, 5 days program. You will get a certificate from IIT Patna, countersigned by other 2 participating organizations, including Vidya Sangha. And there is a little write-up about the importance of Patna city for India, etc. Read up. And basically 10 hours. First 2 days, there will be speeches by IIT Patna and Vidya Sangha, and then remaining 3 days, dedicated sessions on C, C++, and coding. And it will be deep dive onto coding stack development. And I strongly encourage, after listening to my talk, take note of this November 2nd program, and I encourage you to register for that. And I come to conclusion. Some of our attendees are from various organizations, and Vidya Sangha had made partnerships with some of them. Vidya Sangha has been actively putting its time and efforts on developing standards for Bureau of Indian Standards, working closely with leaders of Factory.io to take intelligent manufacturing to 20,000 manufacturing companies in India, and International Aviation Organization, International Institute of Aviation, where Vidya Sangha is also a partner with them. So basically, to take this entire discussion as a summary, LTE currently is the most foundational and the most basic wireless, similar to the days of GSM, which became basis for all evolutions. Currently, LTE is the basic, and based on that, different implementations of LTE have taken it to 4.5G and then 5G. And then OFDM became FOFDM, filter bank OFDM. And then SDN, NFV are acting as a catalyst. SDN stands for software defined networking. NFV is network function virtualization. European Telecommunication Standards Institute management and orchestration, and there is the concept of network slicing. These are the key drivers of the entire 4G, 5G, beyond 5G and NTN. 5G NG RAN for NTN. A new generation RAN is developed to take care of the flying objects like UAVs and spacecrafts for the next non-terrestrial networks. And 6G would be predominantly dealing with the SATCOM and combination of ground-based and as well as flying objects like UAVs. Three-dimensional, that is called 3D, and vertical mobility. Therefore, my conclusion is the old statement of sky is the limit is wrong. That is the proof of my talk. Thank you very much. And I am now open to any question answers.
Thank you, sir.
Thank you, sir. Thank you for the wonderful talk. I now ask any questions from the participants.
Sir, there is a question is posted in the chat box. Madam, can you read out?
Yes, sir. Sir, it's a question from Mallikarjun Gowda. He wants to know about role of cognitive radio in 5G networks. Role of cognitive radio in 5G networks.
Yeah, Dr. Mallikarjun Gowda, sir, welcome. And actually, this subject is researched by many of the IISc folks. Cognitive network is a concept of primary user and a secondary user. And I mentioned about 80-20 rule. If 80% of money is paid by somebody, and that is the primary user, and if they are not using it, let us say they went for 15 days international journey somewhere, and those 15 days the network is still running, and why do you waste it? So the secondary user, given the fact that primary user is not using, they can be utilized all the services of air interface. But when suddenly they come back from airport, they want to do some network, the network should first give priority to them, address their requirements. Until then, when there is a conflict of interest between two parties, first priority will be given to the primary user. That is how the cognitive radio concept is implemented, and it can be implemented on 5G, 6G, even backwards also. But as networks are evolving, as the software-defined radios, software-defined networks, network function virtualization are becoming more and more feasible. I mentioned Linux Foundation's blueprint Archino. Like that, those blueprints are also available for engineers to reuse. It will be now possible to implement more easily the cognitive radio implementations than during the 2G days or 3G days. Actually, every time it is possible, but 2G, 3G days, they were more hardware dependent. The entire switching room used to be air conditioned and a huge space for those racks, and they used to generate a lot of noise, and for safety you need to have big fire extinguishers, and all that is now reduced to a invisible cloud, a native cloud, and there are forums like a open connectivity forum consortium, and there is also open RAN. With that, cognitive radio now more than ever, it is a lot more possible, not just by 5G, even going forward, 5G, beyond 5G. Thank you.
Thank you, sir. So there is one more question from Ramaya. He wants to know like what infrastructure is required to establish 5G in India. What kind of structure is required for establishing 5G in India?
Yeah, it's a good question. First and foremost, there are 4 documents developed by government to think tank about Make in India 5G. Another is a TRI paper on 5G, Telecom Engineers Center, Engineering Center, and also we have TSDSI, like a frugal 5G by Dr. Abhay Karandikar. There is something called a 5G for Indian community. It means rural applications or low bandwidth applications. So it's not always about high bandwidth, high data rate. Maybe solving some fundamental problems that our villages have, maybe in agriculture or some other issues. We have a project known as BharatNet. So there are some gaps there. And if a 5G company doesn't want to waste time, they want to utilize the fiber optics laid between 2 villages. they can come to government and take BBNL, Bharat Broadband Network, and quickly establish their 5G network. Therefore, 5G in India is already government has allocated sub 6 gigahertz, a range between 3,300 to 3,600. 300 megahertz is allocated for 5G under 6 gigahertz. Above that, that is called frequency regime number 2, FR2, where you have 28 megahertz, 36 megahertz, and even going up to terahertz range, where we talk about Li-Fi, light fidelity, just like Wi-Fi. And so the 5G is two aspects. One is below 6 gigahertz, there is an implementation you can do. Above 6 gigahertz, you can do millimeter waves and microwaves and massive MIMO and beamforming. So these are all the opportunities you have. Similarly, how do you take the UAV related communication or a satellite communication 5G? So to do that, you need to first apply for frequencies. So there are two kinds of frequencies, license free and licensed ones. License free is around the WLAN. Telecom Regulatory Authority of India liberally opened up some frequencies around 3 gigahertz to encourage some small players of 5G to do experimentation without paying money as a license fee. And later on, if you really want to run a service like a telco, like Airtel or Reliance, you need to have the licenses, which is a huge investment you need to do. One individual cannot do, but conglomerates or private companies such as Airtel, Reliance, Vodafone. Are you able to hear me?
Yes, sir. Yes, sir.
Yes, sir. Yes.
Yes, sir.
Yeah, I have a couple of questions.
Yeah.
This is Dilip Kumar, sir.
Yeah, Doctor.
One is related to Mr. Ramaya's question, maybe an extension of his. Actually, for 4G, base stations have a bit larger coverage. This one, they cover for larger areas, like in terms of kilometers, like 10 to 15 kilometers, right? So when it comes to the 5G, the range of 5G is not so great, right? So will the existing base stations work for 5G, or any upgradations or any alterations should be made, modifications should be made for the existing infrastructure?
Yeah, it's a good question, sir. I'll go back to GSM days. Technically, 17.5 kilometer has been laid as the radius of coverage of a GSM base station. Practically, when it came to 3G, it became 5 kilometer as the tower to tower distance. And for LTE, it became like less than a kilometer or a half kilometer. A recent survey done in South Korea indicated inter-site distance as 167 meters. The reason for decreased coverage area is not the inability of a wave to travel. They can travel a long distance, but the problem is in capacity to serve. Let us say I am MTR in Indira Nagar. I can only serve, let us say, 100 people. But technically, I can do more of advertisement and attract 1,000 people, but I will end up serving them only 100, and other 900 people will not be served. So that is the reason why coverage is restricted. So when it comes to 5G, coverage will be similar to the way your modem at your home for your fiber optic cable landing on your Wi-Fi router. It will exactly be similar in nature. In terms of the distance will be like 10 meters to 50 meters. And power radiation from them also will be very minimal. Unlike a lot of negative campaign going on right from Robo 2 movie, or in London, they burned some 5G tower that it is spreading the COVID-19. All these are absolutely false propaganda and completely misguiding the people, non-technical and no scientific rational basis at all. So 5G compared to 4G, the towers, existing tower can be used to add another radio for 5G. And that is how they don't need to again install new towers for 5G. All the existing
So the number of repeaters will be more, right?
Yes, and there will be new solutions and serving local area. And also you need to have antenna-less devices. You may not see the big tower-like structure, but it will have a self antenna like our Wi-Fi router. It will have its own built-in antenna structure, which will be like ubiquitous, as Dr. Venugopal sir said. You will not even come to know that there is a tower. There will be also morphing in some of the areas. You may look like it's a plant or a tree, but it's a base station. They camouflage it. So like that they will do, so that people have a negative opinion about these wireless systems. So the industry has these smart solutions to avoid giving too much of a sense of apprehension or a fear or a phobia about these wireless systems.
My second question is, when you start from internet days and 1G, AMPS, 2G, 3G, 4G and all, the upload speed is not matching with the download speed because we'll always download more than what we upload, right? So, but when it comes to the technologies like IoT and other things, the exchange between the data between two devices, the upload and the download speed need to match in many of the applications, right? So, but how do we match this kind of upload and download speeds? Because upload, we still talk in terms of Mbps and download with Gbps, right?
Right.
So how do we match with this?
Right, I will tell you. In fact, there are two separate paths. And in fact, upload can be not by individual devices. In case of IoT, what happens is wireless sensor network will have 50 devices, out of which 3 or 4 may be having a radio functionality, and others will be using Bluetooth or near field communications or other techniques like a Zigbee or LoRa. It will gather the data, and with the wireless cellular network, one data will act like a gateway for all of them. Therefore, there is that kind of a consolidation going on and a grooming going on. Therefore a service chaining functionality. Therefore, we will get a kind of a level playing field between them. And downlink can be on one spectrum frequency, uplink can be on another spectrum frequency, and downlink can be on a 5G, uplink can be on a 4G. Like that, different antennas can be used, different MIMO techniques and beamforming techniques can be used, and therefore there is no need for that they should be equal. Actually, they can be independently divergent and different.
Thank you, sir.
Thank you very much.
Any other questions from the participants? Sir, I think we have no other.
No. There is one new question in the chat box.
Okay.
Accessing these demonstrations, please let me know.
6C, Madam, 6C appears to be already in the pipeline. Will it be too late by the time we established 5G?
Okay, that I will just take up that question, sir. 6G is still in conception stage, and IEEE and ANTS 2020 will focus on 1 or 2 seminars on that or workshops, but 6G is still on paperwork. But just like 4G itself is fully not implemented, because only 20 megahertz carrier is implemented. Government has allocated 100 megahertz. It means that every telco can purchase more frequency. Every city, they have to buy frequencies. If you put them together, it is like 8,000 megahertz revenue that generate government will get, which is equal to some lakhs of crores of money government will get. So, so fully 4G is not exploited. Similarly, 5G will have its own 5 to 10 years time, by which time the 6G concepts will be consolidated. And usually that lag of around 5 years between paperwork and proof of concept and prototyping and field deployments. Therefore, 6G, we are not talking anytime less than 2030, but 5G will start implementing from next 2 years, and it will go on, because Olympics 2020 July, it was supposed to be where end users were allowed to use 5G, but it did not happen. Next Olympics is also, Japan is very cautious not to commit the date for the next Olympics of July 2021, because McKinsey has published the report that complete clearance from the COVID may be not until fourth quarter of 2021. So probably that is one of the things. 5G will be deployed little slower than anticipated in the world. But for the research community, nothing stops you to do work on the 6G use cases. All the 6G use cases will be still applicable on 5G also. It is just that it has come up at a time when 6G is being conceptualized.
Yeah, the vision is like up to 8G or 9G. People are talking connecting a sensor and a satellite, but still it's a vision.
Yeah, in fact, at that time, there will be a new phenomena in internet, sir, that is known as singularity. Singularity is a time when mankind will have a confusion whether a person next to you is a human or a machine. You will be completely confused. She or he may be looking like a human and blinking the eyebrows, looking beautiful or like a normal, cheerful smile, but it may be a machine next door to you. That is called singularity.
One more question, sir.
Yeah.
In the chart. Sir, some recent news said mobile tower radiations causes diseases like cancer. How to understand?
Yeah, this answer is little complicated to answer. I'll tell you from the division between ionizing radiation and a non-ionizing radiation. All the cellular frequencies, by a study of all the experts in the world, they cleared that they are not ionizing your body. Ionizing radiations are actually, if you are really concerned about wireless radiation, I have this advice to all the youngsters in the call and also elders. If you love someone, do not ever gift them any microwave oven in their lifetime. Actually, microwave industry also is considering to withdraw that product of microwave cooking machine, because what happens is, let us say a typical household. Let us say there is a home keeper and a husband and children went to school, and there are four other neighboring home keepers, let us say. They get together at one place and then they put something in the microwave oven in the kitchen and they will huddle together and talk there. And when it is in operation, it is a 30 dB more power, 1,000 times more than what mobile phone or a mobile tower can give. So that is, and you are in a very close proximity to that cooking machine. So the first principle is avoid using microwave oven. Second is, if you cannot, you put something, a timer like 5 minutes or something, keep it on a slow heat and don't stay there at all. Stay in the hall, watch TV. After half an hour, after it's switched off, because the leaking of the radiation will not be there, then you open the door and take it. That is better if you can do that. So this is a better thing to worry about than worrying about the adverse effects of wireless. The fact of any wireless causing cancer is not proven, but smoking definitely causes cancer, because Philip Morris Cancer Foundation, with millions of billions of dollars being spent by the perpetrator of the cigarette manufacturing industry, out of their profit, they are taking care of their community, their consumers, by putting a cancer treatment, which is like an irony. But I think wireless industry is not that bad, and no need to be too conscious. This is just I think propaganda going on there and not real scientific reasons.
Okay. Venkatesh?
Yes, madam.
Thank you, Venkatesh.
Thank you, sir. We don't have any other further questions. Thank you, sir. Thank you, Kishore, sir, for giving such a informative information about 5G, B5G and NTN. Now I request Dr. Venkatesh, sir, to give vote of thanks.
On behalf of the Department of Computer Science and Engineering, UEC, I, Venkatesh, it's honor and privilege to propose vote of thanks to all the participants. I would like to express my profound gratitude and thanks to Professor Venugopal KR, Honorable Vice Chancellor, Bangalore University, Bangalore, who has been guiding force for all these webinars in the college. Thank you, sir. I would like to express my gratitude to Professor H.N. Ramesh, Principal, UVC, for his presence and encouragement. Thank you, sir. I would like to express my sincere thanks to Professor P. Dipashanai, Dean, Faculty of Engineering, and Professor, Department of Computer Science Engineering, UVC, for our real great moral support and guidance. Thank you, madam.
Thank you.
I'd like to thank Professor Dilip Kumar SM, Chairperson, Department of Computer Science Engineering, UVC, for his constant encouragement and support. Thank you, sir.
Thank you, Venkatesh.
On behalf of Department of CSE, I extend my gratitude to the distinguished speaker, Flight Lieutenant A.T. Kishore, for enlightening us by sharing his knowledge on research and development opportunities in 5G, behind 5G, and non-terrestrial network. We thankful you for your fruitful insights, sir. Last but not least, I would like to thank all the faculty members from the other institute, the distinguished participants from various institutes, the guest faculty, research scholars, PG students for their supportive participations. Thank you all once again. Thank you, madam.
Thank you all.
Thank you all for making the webinar so successful. And now I request all of you to fill up the feedback form. And after filling the feedback form, e-certifications will be provided. Thank you one and all. Thanks for everything. Thank you, sir. Thank you, Kishore, sir. We'll just wind up our webinar for today. Thank you.
Thank you, sir. Thank you all,
Thank you, sir. Thank you, Kishore, sir.
So we'll
Thank
meet
you all
again.
the
sir.
We'll meet
Thank
again
you
at
all
2
the
o'clock.
participants.
Yes,
Thank you,
madam.
Kishore, sir.
Okay, madam. Okay, madam. Okay.
We'll
Thank
meet
you for
again at 3 and then
Thank you, sir.
Yes, madam. Yes,
Yeah.
sir.
Thank you, Kishore,
Sure.
sir.
Yeah.
Thank you, sir. Thank you, Kishore,
Yeah.
sir.
Sir, thank
I
you,
would like
Kishore,
to
sir.
thank Govardhan who joined from US, my
Yes, yes.
Sanskrit fellow
I heard it.
attendee. We are
I heard it.
students of
Good.
Sanskrit from IIT Roorkee, and it's kind of him joining my speech, and so nice of you attending my talk.
Okay, thank you. Have a good day.
Thank you. Thank you, Dr. K.S. Rao from Anurag University also, and all others. Thank you.
Thank
Ma'am,
you
shall
all.
we wind up the meeting, ma'am?
Sir. Okay, sir, ಏನೋ busy ಇದ್ದಾರೆ ಅನ್ಸುತ್ತೆ. We can wait.
So
And
link
sir.
everything, link PPT,
Feedback
everything is
link.
kept in the WhatsApp group. All of you please fill up the feedback link. Thank you.
Yes, thank you all.
Thank you all participants for your supportive participations. Sorry,
ಇದ್ದಾರೆ ಬಟ್ ಅದು busy
The
ಇದೆ.
recording stop ಮಾಡಿ sir. ನಾಗರಾಜ್ ಅದು ಸ್ಟಾಪ್ ಆಗ್ತಿಲ್ಲ ಇದು.
ಯೂಟ್ಯೂಬ್ದು ಸ್ಟಾಪ್ ಮಾಡ್ಬೋದು.
ಹಾ